Good day everyone, I'm Hospiti Martinez, BSCPA 1C, and I'm going to present my research proposal. Catanduanes is one of the main producers of abaca fiber in the Philippines, and as contribution, we need to assist our dear abaca farmers in managing and monitoring their abaca farmland with the use of digitalized data. Project LAPNIS is an Android-based GIS app that focuses on abaca farming. The app presents a model of the farm location, provides statistical data of the abaca farmland, its owner, farm tasks, activities and monitoring, abaca health status, weather information, abaca farming tips, and other geo-information necessary. This will provide a basis in decision making and predictive quality and quantity of abaca yields for every farmer. Thus, it will assist every abaca farmer in managing their abaca farmland. With this app, issues on trespassing, boundaries, conflicts in agricultural land titles, and abaca farming monitoring, disease outbreak, and disaster risk can be resolved. With this project, Philfida has the full access and control over our abaca farmers. Before we continue, let's be familiarized with the following terms: GIS, Geographic Information System; LSP-MCE, Logic Scoring of Preference, Multi-Criteria Evaluation; AFIM, Abaca Farmers Identity Module; GPS, Global Positioning System. Potential innovation in farming is possible thanks to the digitalized data, which has shown wide range of application in agriculture. In connection, farmers must have the insight and skills to utilize this modern application of technology. Let's look at the situation. Lawin sa Parhagot is currently nakiagot at Tio Bandoy's abaca farm, together with his father and his two younger brothers. He is wondering where is the tikgan or the boundary of the farm. Thanks to the LAPNIS app, he is able to identify the exact location. Now, let's start to understand the frameworks of the Project LAPNIS app. Project LAPNIS is created by conducting the following stages. Stage 1, the GIS application development. This process will list all the necessary components to include on the app and the overall application development process, the features, and data. Stage 2 is the dataset gathering. We will encounter multi-criteria evaluation, MCE, as a well-known spatial decision-making method in the field of geography, and the LSP method based on soft computing as an improved GIS-based MCE method to evaluate the sustainability and capability of the abaca farmland. And last is Stage 3, testing, evaluation, and maintenance of the application. Stage 1, GIS application development process. First phase is project planning, which will outline on how the app will look like. The second phase is to build the initial app. The app will use the ArcGIS developer platform for analyzing the geospatial variability of the land. Android Studio IDE will be used for coding, which means the app is created using Java code. We're going to subscribe to ArcGIS developer program, create new project for ArcGIS Runtime SDK, modify project Gradle build script by adding Maven repo hosting ArcGIS Runtime for Android API, and grant access to location. Next is to add the library map. Please enlist the library map including in the implementation of the source code and the GIS-based LSP-MCE method for analysis. This will be done by opening the Gradle build script application and putting the implementation for ArcGIS Runtime SDK for Android 100.4. Allow permission to access online to use OpenGL 2.0 and ArcGIS Catanduanes base map. A GIS-based LSP-MCE to implementation. And last is to include a doc on finding routes and direction widget. Next is to create map component, which are objects, overlays, and layers. This will include the topographic components of Catanduanes, climate, soil type, and the setting of reference layer base map of the app. Add MapView object with Catanduanes as base map, include OpenGL 2.0 engine, GIS map rendering. Last is to add the other features of the app. The app should include a task manager, theme, and other necessary functions. Using the library com.journey apps, Zing Android Embedded 4.0.2, and grant access to camera to create Abaca Farmer's identity module, QR and barcode scanner generation, and app recognition. Task Manager application version 1.1 source code for Task Manager, and add onResume, onCreate, and onDestroy lifecycle methods so that the app can close and open properly. Abaca Farmer's identity module will be given to every registered Abaca farmer for their identity. This will give them access to the app, making it exclusive only for Abaca farmers. Lawin is now drying his newly hand-stripped abaca. He used the app to see the weather status of the farm. The app said that at 3 p.m. there's a 67% chance of rain. Stage 2. Dataset Gathering. Study Area. The total land area of Catanduanes is 149,216 hectares, of which 47,901 hectares are used for agriculture. The GIS dataset covering the entire study area is used to develop the LSP method and the resulting sustainability output map. In order to determine the land capability, the soil data comes from the National and Regional Soil Survey in the Department of Agriculture. For the climate, economics, accessibility, and management perspectives, climate and accessibility datasets came from the regional and provincial data tools, DNR Catanduanes. Datasets. Catanduanes has more than 35,500 hectares of abaca land and about 15,000 farmers living on it. Catanduanes produces about 92% of total abaca production in the Bicol region, accounting for 34.9% of total abaca production in the country. LSP-MCE method. The logic scoring of preference method is a soft computing method that uses logical operators based in human reasoning. This is used to evaluate the given criteria and their attributes. The LSP method includes 3 main steps. Number 1 is to develop the attribute tree. Number 2 is the definition of the basic attribute standards. And last is the development of logical aggregation structure. The attribute tree is created by the hierarchical decomposition of sustainability attributes, which are decomposed into categories according to their usefulness. The LSP attribute tree. The LSP attribute tree, which is a decomposition structure that generates all the attributes that characterized the evaluated objects. 2 independent attribute trees for abaca farmland capability and agricultural sustainability. The attribute trees for land capability and land sustainability for agriculture. Symbol plus represents mandatory attributes and minus represents non-mandatory attributes. The mandatory replicability attributes must be met to determine the evaluation is useful, while the optional applicability attributes do not need to be met to complete the evaluation. Elementary criteria. This represents the individual requirements of each attribute and is standardized using sustainability functions. The applicability functions determine the degree of satisfaction with a particular attribute. Satisfaction is determined in the range of 0 to 1. 0 represents unacceptable satisfaction and 1 represents complete or perfect satisfaction. Values fluctuating between 0 and 1 indicates partial satisfaction. Elementary criteria are combined by LSP aggregator until a final sustainability output map is generated. Logic aggregation structure. The LSP aggregator includes the LSP aggregation structure, which follows the hierarchical structure of the attribute tree. The LSP aggregator expresses a series of logical conditions observed in human decision. The application of aggregators, representing a series of simultaneity and interchangeability, provides a continuous step-by-step logic, which helps provide flexible and incorporate many basic standards without losing importance. So there are 6 aggregators: C+, CA, C+-, C++, C++, and C, going from the weakest, C-, to the strongest, C. Stage 3. is the testing, evaluation, and maintenance. First phase is to compile and run the app. This will test the app's capability through the running and testing process, which contains the configuration of LAPNIS source code, which is the XML file, with Android Studio emulator, including camera testing, SDK, and API behavior, and the compilation and running of the app. Next is to debug. Debugging is a crucial process in the GIS application development process that comprises the activity and the behavior of the app. Next is pre-launching. 20 Abaca farmers will have early access to the app for a month, and we will gather the evaluation and responses of the farmers based on their experience with the app through the software testing lifecycle or the STLC method. Last part is the recommendations. Recommendations are open for responses in the pre-launching phase. That's all. Thank you.